Just 100 years ago, space seemed like an unattainable void to humanity. We could only look at the stars and speculate about what lies beyond our planet. But today, everything has changed. People send probes to the edge of the solar system, land devices on distant planets, and receive data from places where no human has ever been. Sometimes these missions discover things that completely change our understanding of the universe. And some of these discoveries may seem truly incredible.
No matter how much we study space, our minds are not truly capable of grasping the astonishing fact that the universe is infinite. However, a recent discovery may give scientists a reason to rethink everything. Is it possible that the universe has a boundary? And what is the blazing wall that NASA probes discovered at the edge of the solar system? Scientific researchers have been discussing the existence of an intergalactic boundary between the solar system and interstellar space for a long time. However, until recently, humanity's technological capabilities did not allow us to obtain data from such distant regions. Everything changed thanks to NASA's space probes. The strange glowing wall at the edge of the solar system was first discovered in 1992 with the help of the Voyager spacecraft. At that time, scientists considered the existence of this barrier only in theory. However, from 2007 to 2017, NASA scientists launched the New Horizons spacecraft and scanned the sky 7 times to detect the presence of the strange ultraviolet light that Voyager 1 had recorded 30 years earlier at the so-called edge of the solar system. The spacecraft obtained a view of this ultraviolet emission degrees and confirmed the detection of excess ultraviolet far from the sun. Its data is almost identical to the measurements made by Voyager 1. We see the boundary between the neighborhood of the sun and the galaxy, says Leslie Young from the Southwest Research Institute. What is this boundary and why did it form? The fact is that all the planets of the solar system are under the influence of the so-called solar wind. This is a continuous stream of charged particles emitted by the solar corona, forming plasma. It is this plasma that creates the heliosphere around our entire system in the shape of an elongated bubble. However, at the boundary of the solar system, the solar wind completely dies down, and beyond it begins interstellar space, which is mostly filled with hydrogen. The glowing wall discovered by Voyager is the result of the sun's solar wind colliding with interstellar forces made up of neutral hydrogen atoms. It is assumed that when helioparticles collide with hydrogen, they lose their speed, kinetic energy is converted into heat, and at the boundary, a so-called hydrogen wall is formed, which scatters ultraviolet light in a special way. Does this mean that the NASA probe could literally run into a wall? To answer this question, let's take a look at what this boundary actually is. Officially, scientists have called this barrier the Wall of Fire. Let's imagine that we are passengers on the Voyager probe and looking out the window. Our location is 90 astronomical units from the sun. The device is gradually approaching the hydrogen wall. The first thing you see in front of you is the area where the solar wind can no longer resist the interstellar wind. First, a shock wave forms in the heliosphere, an area where the wind speed drops sharply, but its density increases. Thanks to NASA's research, we already know that the magnetic field here has a strange structure, similar to foam. This happens because magnetized matter and small cosmic objects create local magnetic fields that can be compared to bubbles. Next, we fly through the heliosheath. Our location is 100 astronomical units. This is a zone of turbulence where the solar wind slows down and compresses. When the speed of the solar wind gradually drops to zero, we enter the so-called heliopause. Here, the pressure of the solar wind is no longer able to push away the interstellar matter. Thus, the solar wind mixes with the interstellar wind, and finally here is the boundary made of the hydrogen wall. Even though there are no border guards here, passing through this area is not easy. You could say that it resembles a real hell. In the hydrogen wall, there are colossal masses of scorching plasma. According to data from the Voyager 2 space probe, the temperature here ranges from 30 to 50,000 degrees Celsius. Such a hot wall creates a kind of barrier that protects our solar system and prevents about 70% of cosmic air from passing through. That's reassuring because if this protection were to fail under certain circumstances, we would automatically end up in interstellar space. Most likely, we wouldn't be able to survive in such conditions due to the high levels of radiation. If that happened, life on Earth would look like scenes from post-apocalyptic or nuclear winter movies. However, the boundary of the solar system has another interesting feature. It has a small area and low density, so NASA probes can pass through it. The main task is to make sure the equipment survives as it flies through the hot plasma. The same can't be said about Voyager 1. Part of its equipment responsible for transmitting data broke down when it tried to fly through the scorching barrier. That's why all our hopes now rest on Voyager 2, which, according to the latest data, hasn't yet reached interstellar space and is temporarily stuck in the transition zone. NASA scientists continue to receive signals from it, but at the moment they're not sure if it will ever be possible for humans to travel through this barrier of hot plasma. For now, we can't confidently predict how interstellar radiation will affect the passengers of a spacecraft. But let's suppose that our technology has made such a journey possible. What will happen when we fly through the plasma? So imagine that we've managed to do the impossible. We've crossed the boundary and in a sense entered a new reality that has nothing to do with life in the solar system anymore. What happens next? For now, we can only guess about that. There is a hypothesis that behind the wall, we are facing a bow shock. It has the shape of a drawn bow and resembles the wave that forms on the surface of water in front of the bow of a moving ship. A bow shock will occur if the interstellar medium is moving toward the sun at supersonic speed. However, this wave may not exist at all. A study published based on the analysis of data from the IBEX probe indicates that the speed of our heliosphere moving through the interstellar medium is not high enough for this. These conclusions are also supported by data from the Voyager spacecraft. But in order to determine what exists beyond the hydrogen boundary, we will have to wait for new data. And now it's time to return to the question that was asked at the beginning of the video: does the universe have a boundary? Since we have established that our solar system has a visible boundary, a logical question arises. Can we apply this pattern to the entire universe? The fact is that in recent years, there have been many scientific discoveries that give us more and more intriguing hints that the universe is not limitless. For example, if we assume that the universe is infinite, then we should talk about its infinity not only in space, but also in time. And that means such a universe would have to have an infinite number of stars. However, when you look at the sky at night, you see dark gaps between the stars. This tells us that the cosmos has not existed forever. And according to the Big Bang Theory, there is a point in time when the universe has a beginning. Our world has not always existed. And all this disproves the theory of the eternity of the universe, and therefore its infinity. The problem is that traveling over vast distances takes light years, and therefore scientists always receive outdated data. At the same time, we don't see all the galaxies. 13 billion years, that's the maximum available to us, says Neil Cornish, an astrophysicist from Montana State University. Thus, for our vision, there is a barrier of cosmic microwave background radiation that formed 380,000 years after the Big Bang, when the universe expanded and cooled enough for atoms to appear. This radiation can be compared to a baby picture of the cosmos, where it is captured before stars appeared. However, beyond this barrier, there may exist either boundaries or an infinitely continuing universe. We cannot obtain definitive data on whether the universe has a boundary or not. But by using mathematical calculations and studying the microcosm, scientists have already developed working theories and have even suggested what shape the universe actually has. Times are changing. Even during the ridiculously short time that humanity has existed on this planet, countless events have occurred, flashing by like images in a kaleidoscope. It's especially interesting to observe how attempts to travel various distances have evolved. Of course, you can't get very far just walking. But gradually people started riding horses, switched to cars, launched airplanes into the sky, and now visiting a neighboring continent no longer seems like a supernatural event, as it did in the days of Christopher Columbus. In a few more decades, we will no longer be surprised by flights of Earth-made spacecraft to other planets and into deep space. But for now, the objects launched to explore the universe invariably attract public attention. Perhaps this is due not so much to natural curiosity and the thirst for knowledge, as to the hope that we will eventually find ourselves a new home. Be that as it may, on October 15, 1997, when the Cassini spacecraft was sent to the mysterious Saturn, humanity could not contain its excitement. Although the main goal of the spacecraft, which carried the 320-kilogram Huygens probe on board, was to study the ringed giant, it also briefly visited the vicinity of Venus, Jupiter, and some moons. Why was it necessary to spend resources on this? It's simple. The specified objects were used by astronomers for a gravity assist intended to increase the speed of the stations. So what did Cassini look like? What is it equipped with? And what were the objectives set for the interplanetary spacecraft? Let's start with the last one. In addition to entering Saturn's orbit, the spacecraft had an additional goal: to carry out the soft landing of the Huygens probe on Titan. The station handled these tasks excellently. This is evidenced not only by the research conducted, the numerous photos of Saturn's rings and the planet itself, but also by the fact that Cassini-Huygens lasted not 11 years as originally planned, but a full 20 years. What are the station's specs? Its weight was 5 tons and 710 kilograms. Of this, as already mentioned, 320 kilograms were allocated to the Huygens probe, 336 to the payload, and 3,130 kilograms to fuel. The height of the spacecraft is 6.7 meters, and the width is 4 meters. The spacecraft is equipped with 2 main engines and 16 auxiliary thrusters. On board, there were 12 highly sensitive instruments operating, including a camera system, a powerful radar, a magnetometer, and a spectrometer. The well-designed scientific and computing systems allowed Cassini to last for a very long time, gathering a wealth of valuable data and photographs. The first artificial satellite of Saturn transmitted 635 gigabytes of data and 453,048 images to Earth. Among them are unique ones that were previously inaccessible to any other spacecraft. The brainchild of NASA and the European Space Agency managed to photograph the area between the rings and the giant itself from an incredibly low altitude. as well as the stunning polygonal hurricane that has been raging for centuries at one of Saturn's poles. The famous photo of the solar eclipse was taken from a distance of 2 million kilometers. In the photo, near the ring system, you can see a faint dot. That's our Earth. But don't think that during the journey to its final destination, Cassini was in hibernation. In passing, the spacecraft captured images of the asteroid Masursky and conducted a photo session in Belarus. Then, it passed near Jupiter on its way back. Moreover, the images were highly detailed, features as small as 60 kilometers in diameter. As it flew past Titan, Cassini recorded a strange formation on the moon's surface for the first time from a close distance. It turned out to be a cryovolcano made of nitrogen ice. Overall, the mission, which cost $3,260 million more than paid for itself. On June 30th, 2004, the Cassini spacecraft firmly settled into Saturn's orbit at a stable speed of 15 kilometers per second. The Huygens probe landed on the surface of Titan a little later, on January 14th, 2005. Approaches to many of Saturn's moons were planned until 2008. Rhea, Enceladus, Tethys, Mimas, and many others. The spacecraft successfully accomplished this, as shown by photographic evidence. The results of the mission are significant and amazing. On September 5th, 2005, the presence of mysterious spokes, bands that run across Saturn's rings and periodically disappear, was confirmed. Astronomers had observed them as early as 1977. The Voyager probe also observed these anomalies from a distance in the 1980s. However, the origin of the strange spokes is still unknown. Perhaps these are Saturnian lightning bolts. By autumn, he had discovered 7 new moons of Saturn, named Methone, Pallene, Polydeuces, Daphnis, Anthe, Aegean, unknown. In St. Petersburg, unknown it was, unknown in St. Petersburg. The spacecraft flew close to Phoebe, capturing for the first time the uneven, heavily cratered surface of the object, and also amazed people on Earth with images of the frozen dumpling-shaped moon the size of New York. The most significant discovery was the detection of methane lakes on Titan. Also, one of the bodies of water is about the size of the Caspian Sea. It turned out that winds blow on the moon that are similar to those on Earth. It rains and thick fog descends. Cassini also observed the giant hexagon, an incredible storm at the planet's north pole. The precise shapes of the structure, spanning 25,000 kilometers across, remain unexplained to this day. Although the hurricane was first observed back by Voyager 1, but it was Cassini that sent clear photographs of the incredible storm back to Earth. The mission was extended twice, but everything comes to an end eventually. So, on September 15, 2017 at lunchtime, the spacecraft was plunged into Saturn's atmosphere. The last minutes of its life were broadcast by the American Space Agency as a tribute to the spacecraft, which had faithfully served science for 2 decades. There is also a farewell photo from Cassini showing Saturn's impenetrable atmosphere. Why did the spacecraft end its mission this way? Several options for ending the mission were considered. Cassini's transfer to an elongated orbit, as well as sending it toward Uranus and Neptune. There was a rather exotic option that required crashing Cassini into Mercury. This event could have happened in 2021, as a result of which astronomers would have become acquainted with Stalingrad. But most importantly, thanks to this costly mission in every sense, humanity learned more about the world surrounding Earth, admired the northern lights at Saturn's pole, and became closer to its rings. What kind of budget do you think is needed to become the first space tourist on Mars? $10 billion according to Elon Musk. That's the amount you need to easily leave the bounds of our vast planet. But did you know that you have the opportunity to see the beauty of Mars and hear what it sounds like without leaving Earth? In recent years, humanity has made great strides forward. At the time this video was made, it had been just over a month since Perseverance landed on the surface of the Red Planet, and specialists from NASA continue to receive the information it has collected. On March 17th, NASA released an audio recording made on March 7 using data from the microphone installed on the rover, and it lasts a full 16 minutes. We have already heard the sound of the Martian wind, and now we can analyze the noise made by the rover itself as it moves across Mars, where it traveled just over 27 meters. And this is really very curious, because in addition to the squeaking of the rover's tracks, the recording also captured some rather interesting knocks and tapping sounds. On the SoundCloud website, there are two versions of the recording, the full one and a shorter cut where extraneous noises have been filtered out. Listen for yourself. What do these sounds make you think of? Here we hear the Mars rover starting to move, followed by metallic tapping sounds. The tapping is also audible elsewhere in the recording. And in some places you can hear a real rumble. Doesn't it sound like Martians are attacking Perseverance and trying to break into it? But everything is explained much more simply. Many people, when they see a picture of the Mars rover, don't realize that the wheels are made of metal. When you drive on these wheels over rocks, it's actually very noisy. Vandy Verma, senior NASA engineer in Southern California and Perseverance driver, commented, "Why are the recordings from Perseverance so important to us? Perseverance is the first. It's the first Mars rover that managed to successfully record and transmit audio from Mars, since previous attempts had failed. Microphones were installed on the Mars Polar Lander rover, which crashed during landing on the surface of Mars, and also on the Phoenix lander, which, despite a successful landing, couldn't make recordings due to electronics problems." But that's not all. The rover's cameras also captured a real Martian dust devil, which is another name for a field whirlwind. We don't know its speed or height, but it's known that dust devils on Mars can reach up to 8 kilometers in height. The mechanics of their formation are the same as on Earth, and it consists of the interaction between the sun-heated surface and the cold and hot air currents above it. From space, such whirlwinds look like this. Impressive, isn't it? What do you think? Could such natural phenomena on Mars hinder future colonization? Write your opinion in the comments. But let's get back to Perseverance. Perseverance is already making real breakthroughs, far surpassing its predecessors. And who knows what we will see and hear when the cameras of the Ingenuity drone, which is still charging, turn on and it soon begins its flight around Mars.